Alright, welcome back. So this is might be a bit long, but we're on 4.2, the unit circle. So before we start the unit circle, we first need to see what are some special angles that we will use and we'll use most often for unit circle. And some of these angles come from like special triangles. So let's look at some special right triangles. Special right triangles. And if we remember, our special right triangles are these two triangles. When I have 45, 45, and 90, as well as this, a 60, 30, and 90, 30, 60, 90. We'll talk about it first in degrees, and we'll change it to radians in just a bit. So 45, 45, 90 triangles. These have a special property where the sides have this ratio. When triangles have the same three angles, all the sides are in the same ratio. And so I'm going to use the simplest version of each ratio. 45, 45, 90, we have 1, 1, root 2. And this is true because of Pythagorean theorem. We could use that to check. A squared plus b squared equals c squared. And for 30, 60, 90, we have 1, root 3, and 2. So these are some special triangles, and these angles are important for when we do the unit circle, when we do trigonometry. Some other trig that we must remember is trig functions. So trig ratios, where we have sine. Let's use theta first. Sine, cosine, and tangent. Tangent a bit less so, but the other two are still pretty important. Where if you do SOHCAHTOA, I like to write it with like SC and T capitalized, so it's a bit more clear. We have opposite over hypotenuse, adjacent over hypotenuse, and that's not it. TOA. Opposite over adjacent. Say these trig, we have these. This should be a little refresher and Pythagorean theorem. We use these, and so first convert all these angles into radians. So we know 90. But let's go in order of some angles that we will probably use. So 30 is the smallest first. So 30 degrees. When we convert it, we actually get pi over 6. 45 degrees, we end up getting pi over 4. And 60 degrees, we end up getting pi over 3. We will use these more and more, and as we use it, I would say please still try to be intentional as we use it, and try to not necessarily memorize, but recognize that pi over 6 is very small. It's 1/6 pi, and 1/6 of 180 is 30. But always think of it as like 1/6, 1/4 pi, and 1/3 pi. And 1/6 is smaller than 1/4. 1/4 is smaller than 1/3. So now we have these values. Let's use it to start constructing the unit circle. So the unit circle is a special circle where I think in this lesson I might just construct quadrant 1 and show us the whole circle. So let's just use this as my circle. The unit circle is a special circle where the radius is 1 and it's centered about the origin at 0, 0. And with the unit circle, there's two things that we want to care about, that like we want to label. In class we did three things, but we don't really care about degrees at this point, so we're going to leave degrees to the side. So starting at 0 radians, we want to find the coordinate. The coordinate for this one is pretty easy. We have 1, 0. The next angle that we care about is we want to do intervals of 30, 45, 60 in each quadrant. So as I bring it up, we have this right here with pi over 6. I'm going to take this out and see what can we do with this pi over 6. So this pi over 6, what we know so far is I know my radius is 1. I want to find the x and y coordinate. And my x and y values are actually embedded right here. We have my x right here and my y over here. Drawing this once more, you end up with this type of triangle, where I have a little triangle with an x, a y, a hypotenuse of 1, and this angle is pi over 6. All I did was draw a line straight down to the x-axis, and we got this triangle. And here's where the trig comes in with circles. We want to now find the x and y values using an angle and using this side. This is done, looking back up, with these trig functions. I see sine theta is opposite of hypotenuse, cosine theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So in order to find x, I have my theta, my angle, I need my adjacent, my x, and I know my hypotenuse. So we end up with cosine of theta equals adjacent over hypotenuse. Plugging in what we know, we have cosine, I'll see the theta for now, is equal to x over my r or my 1. So cosine theta equals x. Just because my r in this case is 1. Cosine theta equals x, or it would be x over r if r was not 1. Similarly, sine theta equals opposite over hypotenuse. So sine theta equals y over r, or y over 1. So sine theta equals y. And tangent would be, you could do it as a little exercise, but to speed it up, the little answer for this would be tan theta is equal to opposite over adjacent, or y over x. But the point ones we care about at this very moment is cosine and sine, because this gives us our x and y values. Where sine of pi over 6 would give us my y. And when we do sine pi over 6, this is where we want to use a calculator. And because at this point, I won't ask you to memorize these values. We'll see a pattern. We'll see it makes some sense. But sine pi over 6 ends up being 1/2 equals y. And cosine pi over 6 is x. So therefore, root 3 over 2 equals my x. So as you do this, please make sure your calculator is in radians first. And for some certain calculators, try to leave it in math print if you know how to get to that setting. Math print just means I want to leave it in radians, not radians. I want to leave it as radicals, as fractions, and try not to get it to decimals, because decimals, they are correct, but it's limited in scope. Calculators might only give 10 decimal places, and this is exact to the infinite amount of decimal places. So since that's my x value, that's my y value, I would just go back over here, erase this, and see I'm at red 3 over 2, 1 over 2. So let's do it again. The next triangle in this would be if my little circle was at pi over 4. You draw a little triangle, x, y, 1, and cosine of pi over 4 equals x. So root 2 over 2 equals x. Sine pi over 4 equals y. Root 2 over 2 equals y. So therefore, on the unit circle at pi over 4, that angle, you have root 2 over 2, root 2 over 2. We continue onwards, and we could fill in the table as we go. Alright, so I found a unit circle that we could see. So here is this unit circle. I'm going to go through it for a little bit, and we see that for 30 or pi over 6, I have root 3 over 2, 1/2. For pi over 4, I did end up getting root 2 over 2, root 2 over 2. And for 60, or for pi over 3, you get 1/2 root 3 over 2. These should be values that we should get as we just plug it in. And we see that there is some sort of pattern going on. And the pattern is actually, you're going from 0 to 4 in this little scenario, and root, like a question mark, over 2. Either increase or decrease in this scenario. So looking at the y for increasing, I have y starts at root 0 over 2, or just 0 over 2, which is just 0. Then I have root 1 over 2, which is 1 over 2. Then root 2 over 2, root 3 over 2, and then root 4 over 2, which is 2 over 2, or 1. And that follows along. 0, 1 over 2, root 2 over 2, root 3 over 2, and then 1. In the same way, x is decreasing from 1 to 0. 1, 3, 2, 1, 0. This is a pattern that we'll see, and it's not really a pattern you have to memorize, but I think it's good to know that these values, for these exact values, you will always have it in like this form, kind of like over 2 or 1, 0. 1 over 2, root 2 over 2, root 3 over 2, or 1 or 0. And either positive or negative. Okay, now we see quadrant 1, and hopefully we're comfortable with this, like this being 1, 0. And now we get to pi over 2, and I see my coordinate over here. Knowing my unit circle is radius 1, you should get your x value is 0, your y value is now 1, to get a distance where your radius has to be 1. And now as we go into negatives, we see on the circle, circles are symmetrical, so they should match up, but the value that changes is actually in quadrant 2. You might have did this when you first learned trig. Quadrant 2 has a special property where your x values are negative. So you have negative x, but positive negative x, or positive y. Whereas in quadrant 1, we see that quadrant 1, we have positive x and positive y. And these positives and negatives correspond to our trig. So positive cosine and positive sine. Whereas over here, I have negative cosine and positive sine. You see negative 1/2, negative root 2 over 2, negative root 3 over 2, positive root 3 over 2, positive root 2 over 2, and positive 1/2. And negative 1 and 0. And now we go into quadrant 3, where we now have both negative x and negative y. or negative cosine and negative sine. We see these are now all negatives. And finally over here, we end up in quadrant 4 with positive x and negative y, or positive cosine and negative sine. So these are some indicators, we'll do more problems with it in class, of seeing the relationship between quadrants and the coordinates. And it's good to understand that it goes just like the angle, quadrant 1, 2, 3, 4. And these radians, like memorizing 3 pi over 4, 5 pi over 6, as you do graphing, we'll see which ones are important, but the one, like the 5 that I need you to understand and like know where they are these 5. 0, pi over 2, pi, and 3 pi over 2. These should slowly become instant for you. And after you get used to this, I want to slowly understand, like, with the same level of priority. Actually, first off, I think just these 3 are very important. Next after that would be these additional 3. And then the others after, I personally kind of forgot. Like the top half, like from 0 to pi, those I'm pretty comfortable with. From pi to 2 pi, I'm still myself not as comfortable with those. Like right off the bat, being like, what is the degree of measurement of 4 pi over 3? It'll take me a while for me to come with 240. So this is not something you have to memorize fully, but you have to memorize enough to use it flexibly, because you will be asked to use the unit circle quite a bit to find trig values. An example for this would be find cosine of 4 pi over 3. And when you ask you to do this, you won't have your calculator with you, or you might not have it with you. And you have to use the unit circle and be like, 4 pi over 3, on my unit circle, I see that 4 pi over 3 is my x value. Cosine is my x, and my 4 pi over 3 is right here. So this is equal to negative 1/2. If I ask you for sine of 5 pi over 6, I know it's my y value at 5 pi over 6. So look at my unit circle. I find 5 pi over 6. And my y value is also 1/2, but positive this time. So please get comfortable using this. Don't try to rely on your calculator way too much, but make sure your unit circle, you are comfortable looking at it, solving it out. All right. Thank you.